This conference will now be recorded.
Hi, very good morning and good evening, everyone. Welcome back. So last session, we were discussing about how do we, proceed with certain problem statements, right? So one by one. We're taking the architecture standardization, and that is leading to some questions to us. Okay, so we need to solve those particular questions, and so we can, so move from there, right? So yeah. So actually we thought of, so what are the problems we found out? So, so when we actually started doing the work, project setup, so we're having a lot of manual steps, we're having standalone servers, we have a dependency configuration problem, okay? And then we have scalability issues and we have security issues, okay? So with the shell scripting, so we adopted one tool, and this tool, okay, is shell scripting. What this tool did, it helps you in automate certain things, okay? And it helps you in so we avoided the dependency configuration with some help of some DNS. Okay, that's what we have done so far. And then, so moving on with the Terraform, or just understanding the AWS concepts, like you have other problems basically. So the standalone servers we have, and scalability and security issues we're trying to address one by one. Now, when it comes to the, so when it comes to the standalone servers, so one server goes down, so the other server, and the one server goes down, so your application is down. So for the high availability purpose, so now what I want to make is I want to maintain two servers. I want to maintain two servers. Okay, so I have two servers here. All right. And so if those two servers are there, so then standalone machine using multiple servers. Okay, answer is use multiple servers. But actually that is leading to another problem. What is the problem? How to send requests to multiple servers. So use load balancer. So this is the first thing which we are going to solve now. So use a load balancer. If you have two servers, start balancing the load between those two machines using the load balancer. Okay, so how do we do that? So let's see this. All right, so first thing first, I am going to create two machines, okay, and I'll install the same software on those two machines, and we will try to balance the load using load balancer. All right, so how do we do that? Let me go and show this. One second. Okay, all right, so let me go to our account. And here. So I'm going to take two instances, okay, and those two instances, uh, I'm going to install the same software. I mean, server has to be identical, right? So if you are balancing the load between two machines, those two machines has to be identical. So that's where we'll go with the identical machines. All right, and so I will just go and say, so instances from template. Do we have template? I think so. So we have my spot one, yeah. So the number of instances I'm looking is two instances, and I'll just say launch. Like I'm just calling it as node 1 and I'm saying it as node 2. Okay, so I think the machines might be up now. So let's try to connect to them. Node 2, node 1. Okay, so yeah, node 1 and node 2. So sudo set-host name node 1 node 2. All right, so node 1 and node 2, you have two machines here. Okay, so in both the machines, I'll just try to install sudo yum install sudo hyphen. Let me go to the root user. So yum install Nginx. So Nginx is easy for demonstration to understand the things. So I'll just go with this one. So this will be fine. Okay, so systemctl enable Nginx and then systemctl start Nginx. Okay, so systemctl enable Nginx, systemctl start Nginx. Done. Okay, so you have two machines. Let's cross verify that. So you have two machines. So two machines giving the same content. Yes, this machine is also giving the same content. Go to the node 2. This machine also gives you the same content. Okay, so content is same. So you're hitting the two machines, but still the content is same. Now, if one machine goes down, also the same content should be so displayed basically to the end user. How do we make it? Okay, I'll go to sorry, not this. I'll go to Amazon and I will say that on the load balancers. Now, when it comes to the load balancers, there are okay, so three types of load balancers, but just almost like how many days? I think just exactly 15-20 days back, there's another one also came in picture. And okay, so but technically talking about, so this is a classic load balancer, is the old generation one which we used earlier, and there is something called as a network load balancer and application load balancer. So these were two widely used one. This just came in picture. Okay, so need to see what actually does gateway load balancer. We need to deploy and manage a fleet of third-party appliances. Okay, need to see. I'm also not sure. Need to take a look. So yeah, so we'll just understand this. So classic one is the previous generation one. So that means they themselves actually grade it out. It's not really being used in nowadays. But yeah, to start with, this load balancer is easy for you to understand. So that's where I'm creating this classic load balancer. We'll create one by one. All three will create it. So here, okay, and this is a test LB, test load balancer. I'm making it. And so here, the load balancer side, you try to understand the load balancer configuration. Load balancer has two phases, right? So the load balancer is having two things here. So if I just try to keep it here, so this is the load balancer. To the public, actually, how does it reach to? So it also should listen on one port number, so that is 80. And you have some servers in the backend, so where it has to reach to. Okay, what is the port number of them? Okay, that is also 80. So that's where, okay, so this 80 is this, and this 80 is this. Okay, so you have two load balancers here. So that's where, okay, so that's where we just wanted to use this. Okay, now the next one is assign the security group. We have already a security group which we can allow all. Okay, and next, health check. Yeah, so health check. What is a health check? So load balancer is a little bit smart now. load balancer is not going to just blindly forward the traffic. Okay, so it also validates that. Okay, so whether the guy actually wherever I'm sending the traffic is actually is actually receiving the traffic or not. It actually validates that. Okay, rather than just blindly forwarding the traffic. Okay, so it actually does is um, it actually does is okay, it actually just validates whether the guy actually where it is actually forwarding the traffic is good or bad. Okay, whether he's really alive or his service is alive or his service is down. Okay, so these things it will be these things will be okay, verified. So that is where it is just asking that, so hey, how do you want me to do the health check? So do you want me to hit a HTTP and so get the response? If I get the response, I can consider that as good. Or what do you want me to do? So you have multiple options here. So probably you don't want to bother about the HTTP layer. So you just want to send that whether the port 80 is responding or not is fine. Whether functionally it is giving the response or doesn't give the response of HTTP. I mean, HTTP also you can give something like this, page not found also you can get it, right? So something like this. Okay, so like let's say I'll go to the same one, so slash something, you will get page not found. So this is an error basically. But actually my web server is running. So if I want to check only my web server is running or not, then TCP. If I want to check whether my functionally my web server is working or not, then I'll go with the HTTP. Okay, so here in this case, it's already coming as a default. So I'm going with this one. And so this is the tuning part of your health checks basically. So how many seconds it waits for the response? Okay, so for doing the health check, what it do is your load balancer will hit the node and it wait for 5 seconds to give the response. 5 seconds is a very big thing. Okay, so 5 seconds is a very big thing. So because the application world works in milliseconds basically, 5 seconds is too big basically. Okay, so that's the reason. Okay, so yeah, 5 seconds is too much big. Okay, you just understand. And how frequently you want to check it, which is 30 seconds. So every 30 seconds my load balancer will do the health checks. Okay, now if it is unhealthy, okay, for the first, like let's say minute 1, it checked the for the minute 1 it checked the okay, let's say 0 at the minute. Okay, now time is around like let's say 8 a.m. in the morning. 8 a.m. in the morning it started the health check. So and it is fine. Okay, then again it will go and check at 8:30. Okay, 8:30 in the sense 8:00 30th second, and again 8:01 comes again and checks the health check. So that means every 30 seconds it's going to check that, right? So now every 30 seconds is going to check, if it is not able to do a health check for the first time. Okay, so and the second time also it will check. In the second time also the health check fails, then it considers that particular node as faulty node. 2 times it checks. Okay, Amazon checks at least 2 times. Minimum is 2. It doesn't actually, first one time it might go a little bit, the server is busy, it didn't respond properly, your health check, okay, that might be something accurate. But later, okay, it should also failing it up. Okay, then you consider that as a failure. That's where the unhealthy. Whereas the healthy, okay, healthy is actually checking 10 times. 10 times means 5 minutes it will check continuously whether it is good or bad, then it will decide that. Okay, so even if I want to make it more responsive, so this one also I'll make it 2. So 2 times if you find that particular one as no response, then consider that as unhealthy. And 2 times you're getting the response, okay, so then put it to healthy. Okay, when coming to healthy, there is no hurry, right? When you're putting the node to healthy, start sending the traffic, there is no hurry required actually there. But whereas unhealthy is actually hurry required. Why? Because the end user might might start feeling the failures. Okay, so that is the reason. So yeah, this is how our configuration, the health check details. We're checking, so where the load balancer is going to check the AD port over, so index HTML, it hits it and it gets the response. It wait for the response time. If it is waiting for the response, how much max time it responds? It wait for 5 seconds at the max of responding. 5 is a very big number, by the way. Okay, so even you can go for minimal also, but still that's okay. That's fine. Interval every 30 seconds, and again, if you want to make it more responsive, every 5 seconds also you can make it. Okay, so but yeah, so 30 seconds is decent. Okay, and you're fine. So you want to make it more responsive, go with the little less values. That's it. And so yeah, add EC2 instances. So which EC2 instances you want to add under this load balancer? These 2 instances, isn't it? And just go with the tags. You don't want it anything. Review create. Your load balancer is created. Okay, the load balancer is going to get created. So you need to, this is the description of the information about that one. And you go to the instances basically. So the instances are showing as out of service. Okay, you just need to wait for it to come to in service. It's still validating for the first time you did the, you just added the nodes and or even the load balancer you're creating. The first of all, the load balancer is actually creating in the backend first of all. Then it will come to checking the health checks of this. Okay, so we just need to wait for a couple of minutes so that we can see them in service. Any questions in the meantime? Okay, so now you can see this, those become in service. In service means those are working fine now. I mean, load balancer made the checks and it is working fine. So load balancer is giving one DNS record. Okay, automatically Amazon load balancers will give you one DNS record. So you take it and you put it right here. You see this, you're getting some response. Where are you getting it from? You don't know at all. Which server you're getting? You don't know at all. Try to refresh, just balance the load between those 2 machines. That's it. In which machine you're getting also, you don't know. Okay, so cd/usr share nginx HTML and cd HTML. So vim index.html. Now let's say if I just want to, so put it just node 2. Okay, and just for an understanding, and vim/usr share nginx HTML and then index.html, and I'm just saying it as node 1. Okay, so wait. So now if I try to refresh, somewhere you'll find out this is coming from node 1, right? And try to refresh, this is coming from node 2. So it's actually continuously sending the traffic to those 2 machines. Okay, and the protocol it just generally follows is a round robin. The technical word we use is round robin. Okay, so round robin is nothing but, so basically it's like a cycle basically. So first request goes to first server, second request goes to second server, something like this. Okay, if you have these many endpoints, it just goes one by one, covers everything, and again goes one by one, it covers everything. So that's a pretty simple round robin protocol. So that means there are 10 machines. First request goes to first machine, 10th request goes to 10th machine. Okay, so that's the idea of round robin. Okay, so clear. So how now the load balancer is working. So now let's do some work here. So what is the work is I will just bring down the service of one system. So systemctl, intentionally systemctl stop in Nginx, right? So now this node actually is being detected as a failure after 1 minute. after a minute, your load balancer will try to consider this as a failure. Okay, so immediately you want to make it in the, so then you have to reduce the responses. Okay, you want to make it more responsive application. So then, yeah, so you need to make it, the health checks is going to be reduced, you need to do. So currently it is still in service. You just need to wait for a minute, right? Currently the time is 7:56, so probably we just need to wait for another minute. So then you'll see out of service. Okay, so you see this? You got it out of service. All right, now you refresh this particular load balancer. How many times you refresh doesn't really matter, not this one. So this load balancer, how many times you refresh doesn't really matter. It all goes to node 2 only. So it's coming node 2. Refresh. Any times you refresh, it goes to node 2. Okay, so that's how it's gonna work. Now if I bring the service up back again, so your load balancer will continuously still doing, even if it is a failure also, it continuously do the health check every 30 seconds. And after a minute now, it becomes in service and automatically starts sending the traffic to that particular nodes as well. Just after a minute. So I just want to hit it continuously, rather than here, I will just hit it in the command line. Okay, so while true is a command which takes to an infinite loop. Okay, so call this one a pipegrapher node, and every 1 second you hit it, handling. So now you're getting node 2. Yeah, already node 1 came into picture. Okay, that means it's already healthy. It's been a minute. So if you try to take a look now, try to refresh, you get this one. Okay, so that's how first it was going to 1 2 1 2 like that. It's going, right? You can see that. Okay, cool. Okay, so this is how typically a load balancer works. And what is the load balancer we are using? A classic load balancer. The classic load balancer is a old generation kind of a load balancer, so it is not that great in performance and things like that. But Amazon itself has introduced other load balancers now, and those are the network load balancer and application load balancer. Now if you go with the create load balancer, this load balancer earlier used to take care of TCP and HTTP and HTTPS also, but now they cut this into 2 pieces. Now the TCP is actually given to network load balancer, and TLS and UDP is also associated to the raw content. Okay, and whereas so the application load balancer, they kept it is HTTP and HTTPS. So that's how the same load balancer, the technology has been converted into 2 pieces, and they're giving it now. So if you're actually dealing with the raw content, you don't know what it is inside. The traffic can be the traffic can be a HTTP traffic, that can be a it can be a audio content, or it can be a video content, video streaming content. It's going to be a WebSocket content. Doesn't really matter what it is inside. You don't bother about what is inside. Okay, so then TCP, it's a raw content. You don't bother about anything what is inside. Okay, that's raw content. Whereas if you want to so most of your applications are HTTP applications, right? So today in the cloud, we're talking about so everything on the internet. In the internet means it's HTTP, right? So mostly now that's where this application, most of your applications you deploy in your inside the cloud is some application. So some application, and that's a web application, if it comes to the web and it is HTTP and HTTPS, isn't it? And that's where the application load balancer come into picture. So the only on HTTP and HTTPS you should do that. Okay. Now let's go and try to create a load balancer, which is called as a network load balancer. And another thing, so what actually Amazon has done is previously you're actually capable of adding the instances directly to the load balancer. Now they enhance it a little bit. And they're calling it as target group. Now you need to create a target group. You need to create a target group first for these two load balancers. Okay. So that means just below to the load balancer, there is something called as target group. Now in the target group, so you're going to group the nodes, whatever you want to group them. Okay, so create a target group, and so here it is instances, of course, and the target group name is okay, TG1 or something like that. And which port you want to send the traffic? Yes, 80 port only. And which VPC is the one, or HTTP 1.1 you want to use, or 2 you want to use? 1.1 is still used, so we can just go with that. And health checks again here. So here also you can just make like index.html, or you can, yeah, HTML, and you just go with next. And so there are two nodes actually, node 1 and node 2, and include create a target 2. This is the one you have. All right. So now getting to the load balancers. Now you go with the create a load balancer. So first I'll start with the network load balancer, and this load balancer test-nlb network load balancer. It's an internet facing or internal. You can make it both, either of your choice. And so to which all availability zones you want to balance the load. So I will choose all availability zones. I'll choose all availability zones. So balance the load between all these availability zones. Okay. If any node can go to any availability zone, so that's where yeah, you can go with that. Configure security group. So security group is no, not needed here. Security settings, right? So here register a target, and yeah, new, again it is coming as a new one now. Okay, all right. So TG1, okay, so TG2, already TG1 is given there. And so now here health checks also is the same thing. Now the port actually which is going to verify is a traffic port. So wherever you send that, the port 80, the health check also happens the way, same thing. And healthy threshold is 3, unhealthy threshold is 3. Okay, so yeah, and the timeout is 10 seconds they're telling. All right. And interval is they're giving only limitation of either 10 seconds or 30 seconds. So I'll go with more responsive. Register the targets, and you have these two targets, add to registered, review, create it. This load balancer is getting created. So the state is provisioning. Once it comes to active, we can take that particular DNS name, and if I put it on the load balancer, I mean, if we keep the load balancer basically on the browser, then you will get that particular content. So now it is actually sending the traffic, but doesn't really bother about what is running inside. Okay, so it's actually sending to TCP. That's it. What is inside? No worries for it. Okay, so yeah. In the meantime, so anyhow, why to wait? Basically, I can go with application load balancer also. I'll say test-alb, and so here also choose all the and configure security group. Here security group, allow all, this one, and here new target group or existing target group. So it's already there. So TG1, I'm just giving it. Okay, so TG1, just register targets. It's already there. Review, create it. So the NLB is active. So that means if I go and take this and put it to browser, why it is not coming? That it. I just want to, okay, I don't know, so it's not coming, right? So I want to do a little troubleshooting. So from my local system, so this is my local system, local terminal. So from here, I want to telnet. So there's a telnet command, so you can use that command. Even Windows also it's available. So I want to check it, I want to hit it on 80 port, right? So I'm not able to reach 80 port. I'm not able to reach. I'm not getting any response basically. So the load balancer is really not actually allowing me to get outside. Okay. So then why? Okay, so why is one thing is it's internet facing, this is okay. And if you go to the target group, so those should be healthy. Let's see. Listeners, and it is forwarding it to here. So I just go here and this is what the information it is telling me, and go to the targets, and the targets are healthy actually. Okay, targets are healthy. Yeah, it's coming. It just, I think some latency was there from Amazon in creation. Okay, so even we seen some errors. That's okay. Okay, so yeah, here also now you got the target group getting worked. Whereas the I think the other part also came, application load balancer also came in. So these also you take it and take it on the browser and put it over here, and you get the same topic. This is ALB, test-ALB, and this one is a test-NLB. NLB is a network load balancer. Now you're still getting the content. So, but basically the thing is the load balancer doesn't know what it is serving. That's it. But whereas application load balancer, it knows what it is serving. Okay. That means it is knowing that, the request came as HTTP, it has to send to HTTP. And the same time, you can also go and add a listener. So if you want to say that, you want to put HTTPS also, security also it supports. Okay. It can give you the HTTPS traffic also. This we can detail later, we can talk it about. But yeah, so now you need to understand. So I think going back to the points basically. So the problem statement which we have is how can we send the request to multiple servers? To the end user, it is always one endpoint only. To the end user, it is always one endpoint. Okay. So and we are actually going to so balance the load between multiple machines. So technically one load balancer, okay, will be there. You take any application, you take google.com, facebook.com, you're hitting one endpoint, so that definitely going to be a load balancer, and that particular one is actually going to so forward the traffic to multiple machines in the backend. Okay, so any applications works this way. What is other things we have? So using LB, so for every component is costly. So that means I want to use a single LB, and I want to send the traffic to multiple components. Now I have node 1 and I have node 2. If I hit node 1, then I have to hit only to node 1. If I hit to node 2, then I have to hit node 2. How to do that? Okay, how to do that? We'll just go there. Before to that, any questions on this? Okay, cool. And so the next thing is, the next thing is okay, so how do you so avoid the cost basically, right? Now I want to, like, let's say node 1 is one application, node 2 is another application. So if I want to serve two node 1s, or whatever it is, one or more, even one is fine, right? Even one is fine. Okay, to a load balancer, one node is also fine. Okay, minimum has to be one node. Now if I hit node 1, it has to go to node 1 server. If I hit node 2, it has to go to node 2 server. So then how can I do that? So we can do this with the help of DNS. We can do that with the help of DNS, and your load balancer become smart now. Okay, so what is the smartness involved over here for now for you in this is, so I'll just delete this NLB. This is not really needed. Now with NLB it is not possible. Okay, why? Because it doesn't know what actually it is serving. You ask to serve, it serves, that's it. It doesn't know who is actually, so what request coming in, where to send, that much information it doesn't know. Okay, so probably it can deal only at the TCP layer. If port 80 is coming, send to this target group. If port 8080 is coming, send to this target group. It can do that. It can do that. Okay, so yeah, so that's how it's going to be. All right, and yeah, now what I'm going to do here is I am going to go with route 53. I'm going to take the ALB DNS record, and I'm going to point to this same DNS record to multiple DNS records. Okay, this same record to multiple records actually. Now in the previously, that you have created the DNS records. All the record type you have created is a record. A is nothing but name pointing to an address. Name pointing to an address. Now I'm going to create a record, and the record type is going to be a CNAME. CNAME is one name pointing to another name. Okay, so this is actually, like, let's say node 1, and this is actually going to be a CNAME record, and this is the CNAME, which is the DNS of your application load balancer. Okay, add another record, and so here it actually going to be is node 2, and here it is, and yeah, that's fine. Create records. No, this is CNAME, sorry. CNAME, create records. All right, so node 1 and node 2, those DNS records pointing to the same machine. Now in your application, in your load balancer, what you're going to say is you go to the listeners. Okay, you go to the target group 1 rules. Okay, so first rule I'm going to add here is insert a rule, and the rule is the host header. Yes, the host header is node 1 dot DevOps B 51 53.tk. First of all, I need to have 2 target groups. Let me go back. I need to make 2 target groups. Okay, and I'm going to make that it's a node 1 target group, and actually I'm going to so next, and I want to put node 1 only. Okay, so create a target group. It's actually going to be a node 2 target group, node 2 target group, and click on create, and you put it node 2. Sorry, include. Okay, so this one node, and probably can't I edit it? I just want to put it in the name as -tg, so that no confusion. So here node 1 -tg target group, just to avoid the confusion, because node 1 name, the name is actually telling it as it's a directly node you're hitting. No, you're not actually hitting a target group. Okay, so 2 target groups are there, and each target group, node 1 target group, node 1s are actually attaching, node 2 target groups, so node 2s are actually getting attached. Assume node 1 is one application, node 2 is another application. Now if I go to the load balancer, now I go to the view or edit rules to the same 80 port only. Now I want to add more rules, and the rule is actually telling that, hey, I'm going to insert a rule and state that HTTP host header if it is the request is coming as node1.devops b53.tk, okay, action, send it to, forward it to whom? So send it to node1. Okay, so done. Okay, done. So save it, first rule, and insert another rule. Another rule is actually telling that the host header is coming as node2.devops b53.tk. okay, node2.devops b53.tk, and send it to, not redirect, sorry, forward it to a target group which is node2. Okay, so save it. Now you try to understand the rules. So the request is coming as node2, forward it to node2 tg. Request is coming as node1, forward it to node1 tg. Okay, so yeah, that's the request you are telling. Now if you go and give, so like basically the call command, so rather than hitting the load balancer, so what actually you're going to hit it is node1 dot DevOps b53.tk. okay, how many times you hit it, you will get node1 only. See this, how many times you hit it, okay, you get continuously node1 only. So now your load balancer is a little bit smart there, right? On the browser also. See this, how many times you hit it, it goes to node1 only. Whereas if I change that to node2, my load balancer will understand, okay, the host hit, then the host is actually coming as node2, then it sends to node2. Okay, so now your second point is also is solved, right? So it's something like your Nginx only. I mean, your load balancers are doing something like a reverse proxy here. If you remember your our reverse proxy configuration, so here how your Nginx is actually forwarding the things. If you go here and if you go to say front end here, and you go to the localhost configuration file, now you see this. So your location, so the same Nginx server only you're hitting, but if you hit it with /API catalog, okay, if you want to hit it with /API catalog, you send it to a certain host. User, send it to a certain host. Okay, like that you're doing, right? So the same thing, even this also is possible there in the load balancer. These locations also is possible. If you go to the load balancer and view our edit rules, and if you say that, so header rule, insert rule, rather than the host header, so probably you want to deal with the path also, it's possible. So path is slash, so /API /catalog. Okay, so path is /API /catalog. So send it to someone, it will send it. That's it, to catalog servers. Okay, it's possible. Okay, it's nothing but a reverse proxy it is doing basically. Okay, so yeah, that's how it's actually been done now, right? Any questions? All right, so using a single LB is use single LB for every component is costly, so that's where we want use multiple LBs is a costly, so that's where we want to use single LB. Okay, now question is a single LB is capable of dealing how many requests? Okay, so yeah, let's ask Amazon. Hey Amazon, how many requests do you have? Okay, I think last time when I checked actually, so we had 5,000 TPS. Okay, so 5,000 transactions per second. Okay, so that itself Amazon also will not hit it. Okay, so that's where you can so maximum TPS on AWS ALB. Okay, so you will not get everything, so you have to let's say, I think there is some default number given to you. So if you want more, and so you need to ask Amazon. Okay, so basically you'll get by default some 50 load balancers. Okay, and so you can create some 3,000 target groups basically, and these are all target, that's okay, but how many transactions per second it supports? Mhm. Where is it? Where is it? Where is it? Where is it? No, not here. Somewhere I get that. Where is this? So we noticed that before Sundown Cloud was reporting one-to-one per minute, we're seeing only up to 5,000 per minute basically, right? So it's actually per minute means 5,500K. That means it's actually 500K. That means it's gonna be 500, another 3 zeros. And by actually, he's actually giving minute. So now if I convert that into seconds, some 8,333. I think this is also a big number basically. That also depends upon which region again. Okay, Amazon's which region. Like recently when I actually checked, okay, so for like Mumbai region, okay, so they are giving 5,000 at the max is what we heard from them. But 5,000 is too much, by the way. Okay, 5,000 requests per second. So this is a too much traffic, by the way. Okay, so and I don't think so there will be that much. Okay, so that much traffic usually on the enterprise applications. So probably you will be having some certain websites like Google and all, you might expect it. So Google also, what they do, they'll not have globally one region. So they will they will actually distribute the traffic to individual regions. So that means Indian people always goes to Google is google.co.in. US people will go to .com. Let's say UK people will go to .co.uk. Like that, they actually try to distribute the traffic locally somewhere. Okay, so that's how only they'll achieve. So if you have such global applications, you need to think that way. So, but it's a regional application. I think 5,000 is a too much number, by the way. I never at least okay. So the maximum number I worked is some 32K per day. Okay, so 32K or yeah 30 no, not even 32K, it's 3.2K. Okay, so that means 32,000 this much. Okay, so traffic per day, request per day. Yeah, so per day I think, or per hour, I don't remember, but 32 3 point is number I remember. Okay, so I think per hour only. Yeah, 3.2 per hour if I'm not wrong. Yeah, so yeah, that's also that's also very decent application. So has a lot of platform, has a lot of applications out there, a lot of customers are there, but still 3.2K is what we seen at the max, the peak business. Okay, so we have seen. Okay, so your all design, okay, your all complete design actually depends upon this one only. Your whole design actually depends upon this one only. Everything, how many servers you need, how much capacity you need to maintain, okay, what type of servers you have to take, okay, so how better has to be your design, how your network should be looking like. Okay, everything will be decided with only one point thing: how much TPS. Okay, how much transactions are being expected. Okay, that's the only thing which actually decides everything. All right, so that is how actually we design the application. So based on this only, we start designing the applications. Okay, either from the developers also will design the applications more or less by keeping that in mind only. So if the application is actually kind of if the application is a kind of so very small one, you don't expect that there is a too much load involved out there, then there is no point in then there is no point in so making a very to say like based on the nature of the application, the design comes into picture. Okay, so they choose the programming language, they choose everything, so based on these things. All right, so that is how that is how the things will work. Okay, I just want to show you one small worksheet as well, so how actually we designed it. 1 second. I'm just finding out that doc. Is it? So you see this, okay? So basically, the request. So just try to understand, okay? So here, the request basically, how many requests have been expected? So based on that only, so we are actually changing some numbers, and based on that we are giving, okay? So here, with 100% uptime, okay, let's try to understand this. So for 1K users, you get this much cost because the resources capacity. Okay, for 5K users, we expect this much cost. Okay, for 10K users on the platform, so you get this much cost. So that means you onboard the customers. Okay, the stock market application. So that's where we just so have some capacity planning accordingly. Okay, and behind the scene is all how many resources we want to use, what all the services, and so what all the user. So if it is a prod, okay, so I'll be taking a bigger instances. If it is a non-prod, I'll be taking a small instances, something like that. Okay, so like that, every calculation being done. Okay, and based on that, so some calculators we use in the backend. So some calculations, just trying to project the cost. Okay, so this the cost is expected. Okay, like this, and everything is actually depends upon how much capacity you expect. That's a major thing. Okay, that is the major thing basically, right? So the same way, yeah, it happens. Okay, the one number which decides everything is how much request is expected. Okay, how much bandwidth is expected to reach our application, is going to hit our application. Based on that only we design the things. Okay, so yeah, and coming back to the points, so this point is also clear for you. I think the number whatever they provide is a too much number. Okay, you don't have to bother about that as well. If you are going behind those numbers, okay, then you have to start splitting it. Yesterday was someone was asking us one question: why don't you use multiple load balancers? Now multiple load balancers come into picture. Yes, of course. Why? Because I have to split the things. Okay, so yeah. All right. Any questions? Any questions? Confusions? All clear? All right. And the next thing is going to be is and the next thing is going to be is okay. Yeah, so this problem 4 is done. Now, is all servers are going to be public? Is it secure? Yeah. Is it secure that if we keep all our servers public? No, it's not. It's not secure. So that's where we wanted to, so then they are vulnerable basically, right? So that means someone will try to hack your machines, they'll try to continuously hit your machines, and even unnecessary you actually make your unnecessarily you expose your server. Someone try to continuously hit your server, becomes busy in rejecting him rather than serving you. Okay, so that scenarios will come into picture if you go with public. One second. Okay, so yeah, and yeah, so we don't want to get it exposed our servers. Our servers will busy rejecting them rather than serving our purpose. So that is the reason. So that is the reason I wanted to talk about something called as how to make your servers less vulnerable. So by using multiple ways basically. Okay, so how do you make them is keep all servers in private network. Keep all servers in private network. Okay, so how do we design this particular private network? So far we are not aware of this particular private public things. Okay, so now how do we make them? All right, so let's see that. And in order to understand, so we need to go with some networking things that Amazon provides. Basically, not only the Amazon, any cloud vendor provides. You just need to understand, and based on that, so we will go with the network design. Okay, so just give me 1 minute. I'll be back in a minute, and then we'll continue. Yeah, sorry. All right, so when we go with the network, basically we need to start looking into a certain networking concepts of Amazon. So with those particular help, we can start, or whenever we want to, okay, so whenever we want to build something, okay, basically the base is the network. Okay, so far you just created the servers, those are getting created, but that's not the right way of creating the servers actually. Okay, so in the organizations, to start with, of course you can do that. If it's a personal thing, that's okay, but if it's a company's project related things or enterprise related things, so first of all we start to keep our boundaries very strong. Okay, it's like a it's like a you just try to understand, like so like let's say you have some fort, how that forts are being protected by walls, right? So the walls is nothing but the boundary. The walls has to be very strong, okay, in order to protect the fort actually, which is inside that, right? So that's a basic idea, right? So the network is the actual boundary, and how much big size you want to keep the fort, and how much big boundaries you have to keep it, right? Okay, that means basically how big your application you want to design. So that particular one you should start looking from networking side. So that means I'm thinking about creating 1,000 machines. my network design should work with some 1,000 machines. If I'm having a plan of going with some 10,000 machines, then my boundaries should have some 10,000, should allow me to put like 10,000 machines. Okay, so the boundaries, right? So the network capacity will be designed based on our based on our requirements. Okay, so now now when it comes to here, yes, when it comes to the networking, so how the design will work, I'll show you now. Okay, so so here in Amazon, so here in Amazon, so we are going to call Amazon, that particular network boundary is called as VPC. Amazon in that particular, so how much big size you want to make it. So it's virtual, basically. It's all virtual, right? Yeah. So how much big you want to design. So that is VPC, which we call it as virtual private. So first you have to say that, so how many IPs? Okay. So what are the things which implies of VPC creation is, very first thing, that is how many IPs we want. Okay, how many IPs we want. So based on that, you design that particular VPC. Okay, so now there are so there are multiple people goes on multiple views, basically. Okay, so what all the views which usually come here is so certain people will say always use small networks, also called as micro segments. Basically, they called as generally micro segments. Okay, so I would say this is a traditional approach, so traditional, and which is a kind of a legacy approach. Traditional, or I would say legacy, old, so these are kind of old approach, basically. But the modern applications, no one want to really go this way. Why? Because okay, the problems involved over here is like, let's say I took a Wi-Fi router, it comes out of box some network. Okay, I just connect. Most probably everyone might have seen that 192 series, right? But what about if I cross those particular IPs? That means I mean that 192 series can max connect off some 250 devices. I cross the 250 devices. Then what is next? So today I started with the business with small. I expected this. Okay, so I thought 250 is too much, but somehow I crossed that. So then what is the problem? I have to take a bigger network. Okay, so that means we have to go with a big network. Okay, so I'll be going with a so rework is involved. Okay, rework is involved. Okay, so this is a problem. So that means if I'm done with my IPs, and so if I'm done with my IPs, so then what I have to go with is I have to go with another network. So I have to go with a bigger network. Okay, I'll go with a bigger network. And if there also it is exhausted, I'll go with even bigger network. So if I go with the bigger networks, okay, then what is the problem? Previously my IP or something, again now that needs to be reconfigured with something. Okay, so okay, your machines are all having Wi-Fi access, it just goes and connects and dynamically get the IP, that's fine. But let's say you have some printers, some devices everywhere, so the devices are actually so hard coded with the IP address. Okay, reserved an IP address. Those every place you have to change the IP addresses. Okay, there's a lot of rework actually involved in this area, but actually people talk is so advantages is secure. Advantages is okay, so secure. Basically how it is secure, it's a micro segment. So some hacker enters into the network, so there's a time for him to enter into another network. He already entered into the network, that means he already cracked something. Okay, he is into the network, but giving rather than taking a chance of opening everything. So okay, so rather than opening a chance of everything, so you can have a small pieces. His boundary is still limited. Rather than he takes some time to get into another boundary, so probably you get some time to block him or something like that. That's kind of a security approach basically. Okay, but this becomes a rework. Okay, rework is not, if I compare the pricing, okay, that how much rework I'm doing, I'm not really interested, right? So every day I'm doing the same work again and again, maintaining by some persons. I'm not interested at least. So the modern applications people, what actually they're trying to do is they will take a start with big networks. Always start with big networks. What is the maximum number? Start with that particular max number only. Most of the people will go with that. And again, also it depends upon how much you want as well. Okay, that all depends upon how much you want. So rather than just taking it everything, you also need to think through that, so how much you can use it. Okay, that also we have to think through. And based on these two criteria, so we come up with some approach, and based on our approach, okay, so we will design the network basically. That's it. Now, okay, now let's say I have some 1000 IPs as a requirement. Okay, so I have 1000 IPs requirement. So 1000 IPs requirement. So either I have to so choose this. I can choose this, and I have to design this. I need 1000 IPs, minimum 1000. 1000 is the design. Okay, based on the design, either I can go with a smaller one around 1000. Okay, so or else I can go with the bigger one, so where I can consume only 1000. Okay, it's up to you. How do we do that? Okay, so that is how we generally design the things. And so I mean, especially in the container world, this is much preferred. Okay, so with the modern applications I'm telling, right? So modern applications, modern apps. Okay, so modern apps needed this much basically for like Kubernetes or okay, so Kubernetes or Docker, any kind of so container technology or container management, I mean container orchestration require more number of IPs basically. Containers means there are a lot of things will run out there, and so that's why more IPs are needed here. Okay, so and even not only about the more IPs basically, it's all dynamic nature basically. More IPs in the sense it might be less also sometimes, but dynamic in nature, so you don't have any control basically. That's the pretty tricky part here. Yeah, again depends upon your application, so I don't want to get into that area for now. So so just keep in mind that your so how many number of IPs you want to design. So what are the factors would just involve over there is, okay, so this is the, I mean this part is only for okay, this part is only for how people approach the things. Okay, but it's not a technical requirement actually. This is really not a technical requirement. Okay, so let me put the technical points here. So so when you go with the VPC creation, so the things you need to design is how many IPs. Okay, how many IPs. So how many IPs? So there's this one you should forecast basically. So these many IPs, the next 5 years I expect it. Okay, now the next 3 years I expect it. Based on that, you just come with some number. Okay, so come with some number, and that particular number will be used to create the VPC. Create VPC using that particular one. Create a VPC. That's what we are going to do. Okay, so all right. Now, if I calculate the RoboShop application, like let's say RoboShop application, so we have how many components basically? We have so 10 components out there. So hardly will run 2 servers. So that means 20 IPs are required if I take the servers. Okay, you have load balancers and everything. So probably load balancer you create, and load balancer create I think 6 IPs by default. Okay, so something like that. So you just calculate everything. So probably you come around 100 IPs, like let's say 100 IPs. If it is 100 IPs, then I have to choose the network which sits under 100. Okay, but how to choose the network which is under 100? So how this network choosing will happen? Okay, so my requirement is 100 IPs, and based on that I have to choose a network. Either I go with a small one, so allocating this 100 IP, or I go with a bigger one and consume only 100. It's up to you. How do you do that? Okay, that's your company's approach. So okay, so companies will always already, I mean, when you unless until you're in a startup, okay, if you're already an established organization, if you are going to work for an established organization, then So then all these things will be already designed, and you're just going to, like, let's say if someone says that, you know, you go with the bigger one, I'm okay. Some people will be there. Okay, so in the present project, you know, so hardly getting a 128 IPs is a bigger challenge for me. Getting a 128 IPs, reserving a 128 IPs is a big question, hell lot of questions. Okay, a lot of bargain. Okay, so it depends upon the people again. Okay, it's all pure mentality. At the end of the day, it comes is you know, the people nature. I mean, nature where they came from, basically, not the nature, technical nature, I would say. Nature where the background they're coming from. Okay, that's also quite important things. Okay, so yeah, things depends. Okay, so that's the reason, based on your organization only, you think through, okay, whether you want to go with a wider range or a smaller range. You know, understand the business nature, and you know, so you do that accordingly. All right, so yeah, that's the idea. So now I want 100 IPs around that. Okay, it's a rough number I'm giving. I don't really require 100 IPs, but still 100 IPs is what I'm expecting now. Based on this, I can go with any of the approach, no issues. Okay, so yeah, fine. Now let's talk about okay, so how to, okay, you know the number now. Okay, 100 IPs is the requirement. 100 IPs is the requirement is this much. Okay, so requirement is 100 IPs. Now how to choose that? I mean, how do you get the range, basically? Okay, 100 IPs, what is the range, and I know how do you get that? Okay, actually, so this IPs, whatever I'm talking about, is IPv4. Okay, so, and there's another one which is called as IPv6. Okay, at least even I have never worked on IPv6 as well so far. So if you're, I mean, why do you go with IPv6 is, so if you go beyond, you know, I think 1.6 crore of IPs. Okay, so then you probably think about that. Then you probably think about okay, IPv6, unless until I think IPv4 is fine. All right, so that's why I'll just go with this one only. Okay, we'll go with IPv6. Sorry, IPv4, and IPv6 is you know, generally out of scope in the backend operations. Probably, like, let's say I took an internet connection, you know, so a year back or some time. So I took a really new kind of guy. Okay, his target is actually, it's Reliance internet, and their target is to go with go with whole India. Okay, they went with IPv6 because 1.6 crore connections at the India level is very small. Okay, because we have a, you know, so 140 crore people, and at least you put by 4. Okay, so which becomes to how much? So by 4, right? So you just okay, so 35, right? So 35 crore, you know, so 35 crore families is expected. Okay, so 35 crore families also. Okay, if he targets, and 35 crores he is targeting, basically. Okay, then IPv4 he cannot actually make it, right? So that's where he went with IPv6. Okay, so that depends upon the business. Okay, how many IPs you forecast? Okay, this is an internet connection guy, and he want to, you know, interconnect everything, and that's where he went with okay, IPv6 rather than IPv4. Okay, so that's the idea of his. Now in the backend operations, we will not have those many machines usually, so that's where okay, you'll always find in the retail things. I mean, in the backend enterprise, you'll not find those many machines usually. Okay, so yeah, and I think this is fine. Now IPv4 is our requirement. When you go with IPv4, it actually IPv4 is nothing but 4 octet. It actually going to start with 0.0.02 to 55.0. Or not 0, 55. So these many IPs you can connect. Okay, so how many of these IPs, basically, this IPs is also too many IPs. Okay, it comes too many. 255 into 255 into into 255 into 255 into 255. So many things are coming. Okay, so much big number it is. All right, these many IPs can be connected over the globe, over the. So assume this is a globe. Okay, so all these machines are under internet. Okay, so internet means geographically. Okay, so these many machines you can connect. But every like let's say I have 2 laptops, I'm not taking 2 internet connections. Am I doing that? No, I take only one internet connection and actually distributing the traffic between multiple machines. So that's where this is a globe and this is internet. All right, and this is a globe and this is the internet basically. And now intranet is also there. Intranet is nothing but a small piece of, okay, so that there's a small piece, my office, this is an intranet. Okay, there I'm going to have intranet. It's not internet, it's intranet. Okay, so intranet is going to be my office building, like let's say in my office or my home, okay, or whatever it is. Okay, I'm going to connect my multiple devices. So but this is single IP only, but to the outside world it is single IP. Okay, but internally you're going to have multiple IPs. Okay, multiple IPs, and that is where, okay, this becomes, so technically this becomes a public, this becomes a private, isn't it? This is a public IP address, this is a private IP address. It's a public IP address and private IP address. All right, so this is how the IP addresses will be. Now this particular public ranges are the total IPv6 classification, or I'm saying IPv6, IPv4 classification is actually being created. Classification. So they did just classify this particular one into what we call 5 classes. Okay, C1, C2, C3, and C4 and C5. These 2 are for non. I mean to say, like, not for user, not for end user. So this is usually for military and some okay, so for some research like NASA and all. Okay, so those falls, and those guys actually use this IP address. Okay, so we don't, as any user, enterprise companies also doesn't have a scope of using these IPs. These are being given to those guys. Whereas C1, C2, C3 is 3 classes: class A, class B, class C, and okay, those particular classes is generally for anyone to use it. Okay, so now let's go and try to understand what is these classes. Okay, all right, so just, yeah, so C1, which is, yeah, it's actually starts from I think it's 1, sorry, it's not 0, 1.0.0.02. okay, so 126.0.0.0. so these many IPs are being, so put it into C1. If any IP you see that's actually 1 to 126, so that actually called as C1. And if it is a C2, so it's actually going to be is 128.0.0 to 191.255.0.0. okay, so whereas the class C is actually going to come from is 192.168.0.0 to 239.255.255.255. okay, so this is the class range for class 3. okay, class B and class 5 we don't want them as well. Okay, forget about that. Okay, so these are the 3 classes which we have. Okay, these are the 3 classes which we have, and in these particular 3 classes, okay, so these are public devices getting connected. Okay, so I have an internet, I should be from one of this class. Okay, if I ask internet that so what is what is my IP address? If I ask internet, okay, it tells me an internet address. Okay, so 49.204.176.10, so which I fall under 121.126. So that means my internet guy, whoever is providing me the internet, so he is actually, giving me IP from class 1. Okay, class 1 ranges. I am getting it. Now for every device, do we take that particular IP address? No. If I put the same, what is my IP address in my mobile, in my laptop, or in my iPad, everywhere, I'll get the same number only. I will get the same number. Okay, so that is how a single IP will be taken out of that and will be, so used internally, because in office you cannot take, or in a home you cannot take an internet connection for each and everything, right? So that's where, so the private IP addresses ranges comes into picture. So the same IPv4, so certain small range, very small range is being given for okay, for companies to use internally. Okay, so and what all those ranges are is so here yeah, so class A, in class A, so they given one range. What is that range is you can use 10.0.0.02 to 10.255.255.255. So that means here maximum how many machines you can connect. So 255 into 255 into 255. So how many machines are there? It goes gonna come. So those many machines you can use it. Okay, so that comes to 1.6 crore, whatever I'm saying, right? So that many machines you can connect. Okay, so when it comes to class 2, okay, so the maximum, so the maximum machines, or the range is 172.16.0.02, 172.32.55.255. Okay, so which actually here is 32 into 255 into 255. Okay, these many machines you can connect. Whereas a C3, okay, class 3, actually they have given a range 192.168.0.02, 192.168.255.255. My writing is bad. Okay, so how many machines you can connect here? Just 255 into 255. Okay, now where is my 100? Where it fits? C3, right? So 255 into 255 is also some 64,000 IPs it comes into, right? So actually I'm going to do this. All right, so this is how and this is how actually we are going to choose which class I want to be on, which class you want to be on. So like, in cloud world, usually people go with a C1 only directly. Take all IPs and consume what you want. That's it. Take all IPs and consume what you want. So that's what people do. Or you want to go with the traditional approach, take minimal. So come to class 3 and start using minimal. Okay. So this is how the things are actually you want it. All right. So that's where I can go with either class 1, class 2, or class 3. Based on my need, I'll go and create it. All right. So now, okay, so these many IPs, okay, so these many IPs, whatever you're having, like 10.0.0.0 to 10.255.255.255. Okay, so this is actually given through a notation basically, so which is also called as 10.0.0.0 by 8. Okay, so you will be having 192 dot, like let's say 168.0.0, okay, to 192.168.255.255, right? So that means it's actually going to call as 192.168.0.0 by I think 16, huh? Yeah, 16, I think. Yeah. So now something is coming up, right? So this is actually something new to you. Okay, so what is this is nothing but a CIDR. Okay, so this piece and this piece is called as CIDR. What it is nothing but is classless inter-domain routing. So with this help, with this particular networking help, what you can do is, okay, so now if I go with the whole range, how many IPs I'm getting? So 64,536 IPs you'll get it. Okay, these many IPs I don't want it. I want to cut into pieces. Okay, so I want to cut into pieces. Okay, so and I want to use that particular piece only. So that means I want only the IP address of 192.168. Okay, so 0.0, I want only 256 IPs, so then I'll go for 192.168.0.255. This is nothing but 192.168.0.0 by 24. If you are interested how this will be calculated, there's an algorithms available in the internet. You can go and so take a look there. But over here, so I mean, you have internet calculators. You can just open the internet CIDR calculator and you put it, and you get the IPs and what is the first IP and what is the last IP. Also, you get it. Now I get only 256. But let's say I want my requirement is okay. My requirement is like, let's say 1024 IP. So then I'll be using is 192.1. Just calculate it, right? So 0.0 to 192.168.4.255 or 3.0 to 3, right? 3.255. 3.255. This is the range I want. And if this is the range I want, okay, I had to use something. So 192.168.0.0. So probably if you go with so 256, right? If I go with 23, it's 512. And if I go with 22, so I had to go with 22, then I'll get 24 IPs. Let me show you this on the internet. Okay, so now what all the IPs you want to get it. Okay, so from that class big range also. So class A public range is a very big one. Out of that, they are giving a very small one. In that small is also very big fun for us, and that also can cut into pieces by how many IPs, whatever you're looking for. All right. So here I can say that CIDR calculator. Now, if I say that if I say that 192.168.0.0, okay, by if I say that 24, how many IPs you get it? 256 IPs you get it. Okay, so calculate, you get this. Or like, let's say I want 1024 IPs, like I mentioned, by 22 you give 192.168 input starting IP. Where is starting IP, input IP? This one, right? You see this 192.168.0.0 to 192.168.3.255. 192.168.0.0 to 192.168.3.255. So now you have to think through that, what is the range you want, and based on the range actually, so you have to choose which class. Okay, and based on the class you choose the CIDR, so that out of the total IPs you can cut only the small IPs and you can use it. Later if you want another more IPs, so probably you create one more network, like let's say 192.168 4.0. okay, 4.0 by 22, one more network come into picture. One more network come into picture, and that particular one is 192.168.4.0 to 192.168.7.255, and some routing should be happening in between those two networks, and you can do that. Okay, so that's the idea. All right, so yeah, so you'll be choosing the network based on your network capacity, so what you're expecting the load, and based on that you design your number of servers and things like that. That gives you some approximate number. Based on that you will be designing that particular one. Okay, so I think for us 256 IP is the minimal one. Okay, 256 IPs is also too much enough for us. Is it too much enough for us? Okay, because ours is a very simple application, right? Not making it too complex and all. Or you want to go with the big one also, start with 10 series, you can do that. I can go and choose one network, like let's say 10.0.0, and I'll say by 16. If I say okay, so I'll get these many IPs. So 65,000, so 65,535, not even 60 by 16, right? So you get even, 65,536 IPs you are going to get it. Okay, so that is how generally you will be. So that is how you generally deal with your network ranges. Okay, once you know the network range, you can go to the Amazon and say that, hey, I want to keep my applications in this network range. So you go to the VPC, Let me delete this load balancer. It's no more needed. Instance is also no needed. Okay, if I go to the VPC, there's already one VPC created, and this guy is actually giving you already giving you those many IPs. Okay, by 16. By 16 means what happens? You know that, right? So calculate. So you get 65,000, but the ranges are from 170 to 31 to 31 to 55. Now, if I want this much range, I can go with that, or else I can go with a simple one, which is 192 series, and I can go with so here, and I'll say create a my VPC. Okay, so which is going to be 192.168.0.0.0, 0.0, 1.0, 3.0, or 100.0 is your choice, by 24. Okay, so this is the range I want to make it. Okay, and I will say you want IPv6, no, so then just click on create it. Okay, so your VPC is created and your range is this much. Okay, so now after that, if you don't directly use them, there is some concept called as subnetting, and we'll talk about that particular subnetting in the tomorrow session. So you cannot directly use a VPC IP address. You have to do some subnetting, and how to do that and all. So probably we'll see that in tomorrow's session. So just one idea. So if you want to design your network, the first thing comes into picture is the capacity planning. Okay, so once after you do the capacity planning, you get some outcome, and that based on that particular outcome, okay, you go with your network. So for startups and all, they cannot actually do the capacity planning because they don't know whether their business goes successfully or it can be going into not successfully, right? So the company can be laid off also. Okay, so any chance can be there in the startups. So for them, there won't be any capacity planning. They go with the bigger one or whatever the number they want, and yeah, they do that. So there won't be any stands. Or if it's a bigger organization and they know the the things which is going to reach. But at least in Agile, you don't expect that, so this much only we expected. So tomorrow anything can happen, right? So your business can go very high, very low. We're expecting to be very high. So that's the idea of Agile, right? So that's where, yeah, bigger numbers is always fine, okay, rather than going with a small number. But our case, we know that, we don't want those many IPs. So I'll just go with the smaller one. That's it. Okay, I think that's all from my side. Yeah, any questions? No questions, no confusions. Okay, all right, no questions. We'll meet in tomorrow's session then. Thank you, and see you tomorrow. Bye. Good day and good night.